study about the liver in human body. Our liver is a simple machine in which a rigid bar turning about an axis. The three components of a liver are the fulcrum, upon which the liver turns, the resistance or weight, the load which is asked to move, and the effort which moves the liver. A liver system is a good example of movement developed by coplanar forces. The articulating surfaces of joints are usually used as fulcrums. The rigid bone shafts extended from axis to axis serve as liver arms, and the source of effort to move the muscles and the liver arms. That is, in the body you have an effort force and a resisting force acting around the forward axis, which is also known as fulcrum, and which serves as a supporting force. When a muscle contracts, the bony liver arm to which it is fixed is pivoted above the fulcrum. Work is done when resistance is overcome by a liver system. Here again is an example that the resistance to be overcome by the body is generally the sum of the load of the liver segment plus the load of the object to move. Here are some examples of simple machines. At one time or another, everyone in the body acting alone or in combination and act as a liver. The human machine offers many examples of first and third class livers especially. Most of the joints of the body can be used as liver of more than one class. In a first class liver, the fulcrum is found between the load and the applied force. An example of a first class liver where the fulcrum is located between the applied load and the effort. Example of first class liver observed when the resisting weight is seen in the tapping of the toes on the floor. When the soleus tendon force behind and the devoted force in front of the ankle fulcrum are utilized in standing. Another example of first class liver includes the elbow joint. The longer the level arm, the less the force is required to move or resist the applied load. Other examples of first-class liver are found when the splenic muscle acts to extend the skull across the atlanto-occipital joint. An exercise forming first class of liver is triceps stiff. Your elbow acts as a middle of the load and effort carried through your hands and the muscle to complete the liver. First-class livers are those where the muscular forces and the resistive forces act on opposite sides of the fulcrum. It also includes in the action of the tricep on the ulnar when the arm is held over the head. Now here you can see the weight of the thigh is the resistance, the hip joint is the fulcrum, and the contraction of the adductor muscle is the effort. A second-class liver has the resistance weight located between the applied force and the fulcrum. Since most of the muscles moving each joint are inserted near the joint and the resistance is usually at the long edge of the body livers. Livers of the first and third classes are most commonly used in the human body. There are no positive second-class liver in the body because the length of the resistance arm of the movement is always greater than that of the effort arm when movement is produced by the muscle shortening. Some kinesiologists refer only superficially to the action of the brachioradialis on the forearm during elbow flexion and the action of plantar calf flexors one stands on the toes as being second-class liver action. A toe second-class liver system can be demonstrated. However, when muscle tension becomes a resistance to a reversal of joint action caused by outside force so that a third-class liver system is reversed and becomes a second-class liver system. In such cases, the eccentric muscular contraction is performing negative rather than positive work. An example of this is seen when one stands on the tip of toes, where the fulcrum is located on the ball of the foot, and the force is applied through the gastrocnemius at the ankle to lift the body weight. In the third-class lever system, the applied force is in the center between the resistance and the fulcrum. This requires a greater force to move a smaller resistance, but maximizes speed and the distance traveled. A third-class lever is found where the applied force is always located between the fulcrum and the supported weight resistance is seen in the action of the bicep in the flexion of the forearm. The bicep inserts between the elbow and the hand. Thus, when the bicep contracts, the elbow joint serves as a fulcrum. The same mechanism is seen in lifting a weight with the foot. So here is another example of third-class lever you can observe in this picture. While playing the football, knee joint acts as the fulcrum, thigh applies effort, and the foot acts as load along with the ball. Third-class lever system example could also be observed by performing the card drill. There is a recap of the first, second, and third class of lever system, where the fulcrum is located, where the effort is located, and where is the load. Now you can also recap the example of the lever system in human body. The force developed when a muscle contracts is determined by the mechanical advantage of the levers employed. The position of the attachment of the muscle in relation to the position of the center of the resistance and the position of the fulcrum are important in deciding the mechanical advantage of any lever. Therefore, mechanical advantage is defined as the ratio of output force delivered to the input force applied by a mover. If the resistance is placed near the fulcrum, the mechanical advantage is good. If the same resistance is placed further from the fulcrum, the mechanical advantage lessens and a greater effort is required to overcome the resistance. Therefore, mechanical advantage is computed by dividing force into resistance, or length of arm input divided by the length of arm output of the lever.